Hey guys, I'm Axis. Today we'll be starting partial differential equations. So we will be focusing on a dependent variable called z and independent variables x and y. So any equation that contains this dependent variable and these two independent variables, as well as a partial derivative of the dependent variable with respect to the independent variables, that is called your PDE. For example, del z by del x plus x times del z by del y is equal to z. This is an example of a PDE. So just note down the notations that we're going to use. Del z by del x is denoted by p. Del z by del y is denoted by q. Del 2z by del x2 is denoted by r. Del 2z by del y2 is denoted by t, and del 2z by del x del y is denoted by s. So basically we need our answers in the form of x, y, z, p, q, r, s, t. Our final answers should contain only these. So let's look at how we form our PDEs. The first method is eliminate constants. For example, z is equal to ax plus by plus a square plus b square. So here a and b, a square, b square, these are constants. We do not need these in our answer. So we will somehow try to find these terms and replace a and b with them. So here I can see del z by del x is a plus 0 plus 0 plus 0. Remember guys, when you are doing partial differentiation, that means partial differentiation with respect to x means you treat y as a constant. So here you only have to differentiate this term. This term will give you 0 as they are considered constants. So del z by del x, which is p, becomes a. Similarly, del z by del y, which is q, becomes b. So now you can replace a with p and b with q. So your z becomes px plus qy plus p square plus q square. So sometimes you are given the equation directly, but sometimes you have to form the equation. For example, form PDE of all spheres with centers on z-axis. So if the center lies on the z-axis, that means the value of x and y is 0. That means the center is on 0, 0, a, let's say. And let's say the radius is r. So as you know, the equation for a circle is x square plus y square plus z minus a whole square is equal to r square. Now let's try to differentiate these. Let's differentiate with respect to x. So you'll get 2x plus 0 plus 2z minus a del z by del x is equal to 0. Remember guys, z is not a constant. It is an equation that is in the form of x and y. So we cannot treat z as a constant. So here I've applied chain rule, twice of z minus a times del z by del x. So you get 2x plus 2z minus a p is equal to 0. That means x plus z minus a times p is equal to 0, which means z minus a is minus x by p. Now let's differentiate this same equation with respect to y. So we'll get 0 plus 2y plus 2z minus a del z by del y is equal to 0. So again you're gonna get y plus z minus a times q is equal to 0. So z minus a becomes minus y by q. So now as you can see, these two equations are equal. They are both equal to z minus a. Hence minus x by p is equal to minus y by q. Minus and minus get cancelled. So your answer is qx is equal to py. This is your answer. So this was the first method. You eliminate the arbitrary constants. Second method is eliminate arbitrary functions. So for example, you are given a function phi of u comma v is equal to 0. Here u and v are functions of x, y, z. So if you differentiate this with respect to x, you get del phi by del x which you can write as del phi by del u times del u by del x plus del phi by del v times del v by del x is equal to 0. And if you differentiate it with respect to y, you'll get del phi by del u times del u by del y plus del phi by del v times del v by del y is equal to 0. So you guys might have studied Jacobian. So u and v are always functionally dependent. Which means Jacobian of uv by xy is equal to 0. You do not need to remember this, just remember this. ux uy vx vy is equal to 0, where ux is u differentiated with respect to x, uy is u differentiated with respect to y, vx is v differentiated with respect to x, and vy is v differentiated with respect to y. Remember these terms. So let's just do an example so you understand this better. So for example, you are given a question phi of x square plus y square plus z square comma xyz. So here this is your u and this is your v. Let's write this down. U is x square plus y square plus z square and v is xyz. So let's find ux. This is 2x plus 2z del z by del x. This is 2x plus 2zp. Similarly, uy is 2y plus 2z del z by del y, which means 2y plus 2zq. Let's find vx. Here we'll have to apply the product rule because x and z are both variables. So let's take y common as it is a constant. So leave x, differentiate z, plus leave z and differentiate x, which is 1. Vy would be, here I'll have to take x as constant, y del z by del y plus z. So now you have your 4 terms. Now let's put it in the Jacobian. So ux, uy, vx, vy is equal to 0. Let's write this down as p and q first. So this is y xp plus z, and this is x yq plus z. So our Jacobian becomes 2x plus zp, 2y plus zq, y xp plus z, and x yq plus z is equal to 0. So let us solve this. 2x plus zp times x times phi q plus z minus 2y plus zq times y times xp plus z is equal to 0. Let's take out the 2. X into x plus zp yq plus z minus y into y plus zq xp plus z. Guys, be very careful when you're solving this. So let's take the 2 to the other side. So x multiplied by xyq plus xz plus yzpq plus z square p minus y multiplied by xyp plus yz plus xzpq plus z square q is equal to 0 divided by 2. Now let's multiply the x and y inside. So x square yq plus x square z plus xyzpq plus xz square p minus xy square p minus y square z minus xyzpq minus yz square q is equal to 0. So this one term gets cancelled out. Now technically this answer is correct, but let us write it in a more simplified form. So I'm gonna take xp common from these two terms. So this becomes z square minus y square plus, let's take yq common from this term and this term. So this becomes x square minus y square plus, let's take z common from these two terms, plus z square x square minus y square. Sorry, this one is z square is equal to 0. So this is your final answer. If you guys have any doubts, leave them in the comment section and I'll answer. Also, my notes are in the description and you can find more practice questions over there. Okay, thank you.